Okay, so a quick review of what we talked about on Friday. Sorry I couldn't be there today, but I should be back tomorrow. Taking a look at number 4 here. This is on page number 22 in your packet here. And just once again, graphing just the equation of the line y is equal to 1/4 x. So when you're graphing an exponential function, all right, we had talked about this before. We want to start by taking our calculator, typing in our graph. So just 1/4 and then caret x here. We get our graph, and then we're going to kind of look at our values. So we can see probably 2 might be a little, -2 might be a little high, but -1, and then going down to, we can get this curve here of values. So Control T, all right, and we can see, at -1, it's at 16, -2 is at 16. That's kind of high, so we're probably not going to be able to fit it, but we should be able to fit these values from -1 to probably 2 in here to get that curve. Okay, so let's do that for ourselves first. So we're going to go ahead and make a table. So here's our XY table. -1 is equal to 4, 0 is equal to 1, 1 is equal to 1/4 or 0.25, 2 is going to be 1/16, which is 0.0625, right? And then we're getting kind of lower and lower from there. So -1, we're at 4. Okay, 0, we're at 1. At 1, we're at 1/4. And then we're already getting super close to the y-axis there. And then we can kind of draw in our curve for ourselves. So let's just make this blue so it's easier to differentiate there. All right, and then we can draw our curve. So remember, it's going to be at -2. It's going to be at 16, somewhere way up here. So we're heading down our curve, and then as we get to the x-axis here, we're headed closer and closer to that number. Now we don't have to go all the way to the end. We can just throw an arrowhead on here, make sure our axes are labeled for ourselves. All right, and then we can go ahead and fill in. So the asymptote to this graph would be this x-axis, which has the line, the x-axis, which has the line y equals 0. The y-intercept is at the point 1, so that's 1. The domain is the x's, okay? In this case, that is all real numbers. And if we wanted to, we could do the set of x such that x equals all real numbers. And the range, once again, is the y's. Remember, it's going to be everything bigger than 0, but not including 0. So we can just say y is greater than 0, and we can do our set builder notation as well here. Okay. Is it a function? The answer is going to be yes for these exponentials. And it is also 1-to-1. Kind of tricky because it is getting closer and closer to the x-axis. So any horizontal line is actually only going to touch once, not twice, even though it kind of looks like it near the x-axis. All right, so the big thing for today is transformations of functions. So we're going to be talking about how to basically take a linear and exponential function and how to translate them. We do a translation. It's going to be up and down, okay, left and right, how to reflect them, how to compress them, and how to stretch them. And usually we talk about these compressions and stretches as either being a vertical or a horizontal. And I know we started on the next page already, so we're just kind of refresh here. So remember, this is when f of x is our function. That's kind of our y value. So if we take the y value and we add k to it, right, we're basically going to shift our graph up, okay? And if it's going to be a minus, we're going to shift down. So anytime we think about the function itself as f of x, if we add a number to it, that's going to shift up. And if k is negative, we are going to shift down. So y equals x is our function. So if I just want to shift down 6 units, just at the very end of the function, I'm going to put a -6. If I want to shift up 4 units, right at the end of the function, so y equals x squared, I'm going to put +4. So we're just going up. It's taking whatever when you plug in for x, It takes that answer and just adds 4 to it. Okay, here we want to shift up 3. This is a little bit trickier because there's already a negative here, but we kind of think of it as negative 3/4 x minus 4. There's the original function, and then plus 3. So this really turns into that negative 1. So this is really going to become, shouldn't put an equals, too many equals here. Y equals negative 3/4 x and then minus 1. All right. If we take our exponential function here and we shift it down 2, we're just going to take our y equals 3 to the x and we're going to subtract 2. And if we take our y equals 1/2 to the x and we shift up 1, we're just going to take our function, which is y equals 1/2 to the x, and we're going to shift it up 1 by adding 1. That's it. So anytime you want to shift the graph up or down, you add 6 to that number to go up and subtract 6 to go down. Okay, horizontal translation. So if h of x, if we have a function, now if you want to affect and shift the graph left or right, you have to add something to the x value. But this is where it gets a little bit tricky. All right, so we have our graph y equals 1/4 x. We're going to use this and we're going to add in, let's hit tab, and we're going to add in 1/4 x, so caret x, and then we're going to subtract 2 from it. So we think normally like you're subtracting 2, it kind of makes it go left, but it actually shifts it to the right. And the reason this is happening, okay, the reason this is happening is because in order to get from this point, which you can see is 4, back to the original function, which is 4, I actually have to move 2 units. I have to take 2 away from the x. So you have to kind of think of this as when you're transforming the graph, it's actually moving this graph backwards to here, okay? So you can think about taking this graph and moving it over to there. I have to move 2 spots to the left. So this graph shifts to the right because in order to get back here, I have to take 2 away from the x. And that's why it's x minus 2 in the equation, but it's actually moving 2 units to the right. All right. So you have to plug kind of like a negative 2 to make it go back to the original. So even though the graph shifts left, it's a minus. Shift to the right is a minus there. So just remember when you're adding or subtracting to the x, okay, it's the opposite of what you think. Okay, so kind of keep that in mind. It's the opposite, all right, number moving left or right. So I don't like how that's phrased. You can kind of talk about how to put this when we get back in person here. Just remember it's the opposite sign from what you think, okay? So if h is being added, if it's positive, it's actually going to shift to the left. Remember, positive normally right, but it's the opposite. And if we subtract, we're going to move to the right. We're always taking it away from the x value. So we want to shift left 3. Remember, that's a plus because we're going left. It's opposite. So it's y equals 2. And then where the exponent spot is, we're going to put parentheses here just to make sure we know that it's associated with the exponent spot. We're going to put x plus 3. Okay. For number 11, we're going to go right 7 units. So remember to think opposite when you're shifting left and right. So this is y is equal to 4 to the x minus 7. Okay, why don't you try 12 and 13? So pause real quick, try these on your own, and then you can unpause and we'll talk about it. Okay, for number 12, we're going right 4 units. So hopefully remember that's opposite. So y equals 2 to the x minus 4 to go right. And this time we're going to shift left 2 units. Remember opposite, so it's going to be a plus. So this is y is equal to, and this is just x plus 10. Now, this graph, even though it's a line, plus 10 actually moves it up. It also shifts it left at the same time. So keep that in mind. Number 14, okay, let's see if you can try this one on your own. There's 2 moves, left and down, and this next one has right and down. Okay, so try these real quick, pause it, give it a shot. All right, and hopefully you ended up with y equals 0.25 Now we want to go left 5, so you got to think opposite here. So that's x plus 5. And then down 8, we subtract from the y, we put it all the way at the end, we put a minus 8. And that's our equation. All right, number 15. So we want to go right 6. So we're going to, that, remember, right is affecting the x, down is affecting the y. So it's y equals 5 to the x minus 6 to go right, and then down 1 we subtract from the entire function. Okay, number 16, same concept here. I'm going to go right 2, so that affects the x and its opposite, and 9 units right affects the y. So it's y equals 1/3 to the x minus 2 to go right 2, and then plus 9 at the end to move up 9. All right, for number 17, okay, we can go graph these real quick. So let's grab a new graph. No, we don't want to save. We're going to do y equals 0.5 to the x. All right. Oh, we did y equals. We ought to get rid of the y's. F of x equals. There's our graph. And then what happens if we make this negative? Now, if you remember, okay, in 7th grade, we talked about our reflections, right? So a reflection in the y-axis takes any point xy, should say x comma y here, okay, and turns it into negative xy. All right, and if you reflect in the x-axis, it takes any point xy and it turns it into x negative y. So if we're just making the whole function negative, right, we're taking f of x, which is the y value, and we make it negative. We make the y negative, it should flip over the x-axis. So watch what happens. So we're going to do tab, we're going to do negative 0.5 to the x, and it should flip over the x-axis. We make the y negative, make the whole function negative. Okay, see how the whole function is negative, f of x is negative, it flips it over the x-axis. Okay, so I'm not going to graph it, we're just going to explain. Okay, so the graph reflected over the x-axis, right? Because f of x, which is y, became negative. Okay, on number 18, all right, we could take a look here. Actually, no, let's go back and graph. We'll go ahead and graph these. So let's pick up our table. So we have 0.5, 0.25. All right, we'll start negative 2, 4. So negative 2, 1, 2, 3, 4. Negative 1 is 2. 0 is 1. And then we're at a half and getting closer and closer here. So heading in this direction. All right. And this should be 8. You can see if we go up, get 8. So negative 3, we just want to make accurate. 5, 6, 7, 8. So we're heading right through right there. So if we reflect it over the x-axis here, these points are just going to be mirror images and the same distance away. So this is down 2, this is down 2 more, down 4, down 4 more, down 8, down 8 more. And then the graph just goes this way. Okay? It heads towards and along the x-axis here. All right. So since we did reflect them, and there's 2 graphs, we want to make sure that we specify which is which. All right. Go ahead and pause it here if you need to finish, and then we'll pick up number 18. So what's happening here? we're making the x negative. So the transformation should be that the graph, all right, graph is reflected over the y-axis. And we can kind of make a table for the first one. So when x is -1, we're at 1/2. When x is 0, we're at 1. When x is at 1, we're at 2. 2, we're at 4. 3, we're at 8 here. So we're going to be increasing this time. So even if it's at -2, it's -1/4. So it's down there. And then we're going up from here. This should be a 2. 2, 4, and then 8. So there's our graph. Oh, we can do better than this. All right. So this is y equals 2 to the x. So we go -x, okay? Then it's going to flip over the x-axis here. So it's going to make the x negative. So we can go ahead and enter that in. So new document, don't save, graph 2 to the x, tab 2 to the -x. And then when we go to table, so we talked about these 2, 4, 8. So if we go the other way, now we're going, so it's -3, 8. Just making the x negative. All right. So -3, 8, -2, 4, -1, 2, 0, 1, 1.5. See, we're just changing these x's and making them negative. So if we're at -3, 8, you can see that it's just a reflection right across that y-axis here. Okay, -2, 4, -1, 2, 0, 1. We're at a half, at a quarter, and now we got our graph coming down. And this one is y equals 2 to the -x. And that's it. Okay, so big thing for the lesson on this one, if you make the y negative, the whole function negative, we're going to flip over the x-axis. And if we make the x negative, you're going to flip over the y-axis. Now the base, when the base is negative, okay, that just means the y value, the whole term is negative, okay? That's like saying -f of x. All right, it reflects over the x-axis. When the exponent is negative, this is like saying when the x is negative. All right, it reflects over the y-axis. So we want to reflect over the y-axis, we make the whole thing negative. So y equals -4 to the x. All right, if we want to reflect over the, oh, sorry, that was backwards. Time out. If we want to make the y reflect over the y-axis, right, remember that we need to change the x. All right, so it should be +4 to the -x. Let's fix that. This should be +4 to the -x. Reflect over the x-axis, right? Remember, we're going to change the y. So this is going to be y equals -0.1 to the x. Okay, big one. Let's try this one on your own. All right, reflect over the x-axis. So remember, we're going to change the y. All right. So we're going to negate the y. 6 units to the left, right? That's opposite side to the x, and 3 units down, we're going to add 3 to the y. So it's y equals negative the whole thing, 5, left 6, so we really want to subtract 6 from the x, and then down 3, subtract 3 from the whole thing. And there's our function. Okay, you guys work on today's homework, and we'll go over this tomorrow. Have a great rest of your day.